There we go. People should start joining us soon. They are already. And let me just put up our little intro. Hope everybody's doing well. So who all got snow?
We got very little.
Well, it's still snowing here.
Oh, there you go. That'll show you.
Lake Ontario decided to breach its banks once again and adorn us with some lake effect snow.
Lovely.
But it hasn't been a lot.
Mm-hmm.
It's actually pretty cold. It's only I think it's down to 9 degrees right now.
We're a balmy 25. So there. Yeah.
John, what does ESF stand for?
Actually, it's the College of Environmental Science and Forestry.
Okie dokie.
Welcome everybody that's joining us. We'll get started in just a minute.
So it's SUNY ESF, but you're also affiliated with Syracuse?
Yeah, it's weird because we basically, when we sign up as a student of ESF, because of the relationship with Syracuse University, we also have to enroll as a student at Syracuse University.
So did you get 1 degree or did you get 2 degrees?
I think I just got 1. I think they only issue them from the State University of New York now.
Clark, 70 degrees where Clark is.
It's always 70 degrees where Clark is.
It must get boring. It has to get boring after a while, you know? Oh, it's 70 degrees again.
A friend of mine graduated from Syracuse and SUNY with a degree in forestry back in 1972. And he got a degree from both schools back then.
Yeah, I don't know. Hey, Clark, you can always head to the mountains. Yeah, I have to. It's an odd situation because we are able to take classes at Syracuse University for the same pricing as State University of New York, which is a bit of a discount. So that's like a fringe benefit. So
good.
Very nice. Well, guys, it's 4 minutes after 7, so why don't we go ahead and get started? I'm sure people still continue to join, but I say we get going, get the show on the road, so to speak. So welcome, everybody. Lori Jensen, Executive Director of the New Jersey Forestry Association. We're glad you're here tonight. Didn't have to worry about it being a snow day, right? We just pull up a chair and watch a webinar. So glad you're here. Just a couple things as far as tonight's presentation. We will take questions at the end. If you can pop your questions in the Q&A at any time, we will go ahead and answer them, or John will answer them after his presentation. So do that at any time. Feel free to stop by in the chat to say hi. We'll be monitoring that throughout the presentation. Andy, how are you today?
I'm good. And welcome, everybody. Yep, save the date every third Thursday. And we are in the process of putting together the entire 2022 list of items that we will be discussing in Backyard Forestry. We're making some great progress. And I think in 2022, you will enjoy a lot of the presentations that we will be putting together. So, New Jersey Forestry Association, I am the president, Lori is the executive director, and John Hooven is one of the directors of the association. We were formed back in 1975, incorporated in 83, and we are the voice for woodland owners in New Jersey. And actually a newsletter just came out and I got my newsletter today. So here's a list of the officers of the Forestry Association. You may know some of those people, and if anybody is interested in getting more involved, we do have openings on the board. So we would, if you would like to be interviewed, we would certainly welcome the opportunity to consider people. So as a landowner representative, we represent a number of different areas within the forestry community. So we certainly have connections with the Forest Service. I sit on the Division of Taxation's Farmland Assessment Committee, which hasn't met in 2 years because of the COVID. We also are involved with American Forest, SAF, Farm Bureau, Outdoor Alliance, Rutgers Cooperative Extension, Tree Farm, the New Jersey Forest Service Stewardship Committee, and New Jersey Community Forestry Council. So if you are not a member of the New Jersey Forestry Association, we would certainly welcome people joining. The memberships have just been going out for 2022, and it's $55 a year. And we certainly would welcome people. With that, you will get our quarterly newsletter, and you get to participate in all the stuff we do. And we certainly are looking for more people to join the organization. So why join in NJFA? Well, I mentioned the newsletter, which just came out today. We have a website. Annual meeting, unfortunately, in 2020 was canceled. 2021, we did remote. Not quite sure what we're going to do this year. We've kind of decided we're going to put it off till April rather than March. Not quite sure what's going to happen with that. Same with the Woodland Stewards program. We had the abbreviated program last year. Backyard Forestry in 90 Minutes has been terrifically successful. That used to be an in-person presentation, always the third Thursday of the month, but we are getting much better participation with the online. For instance, tonight, right now, we already have 108 participants. We've had as many as 450 people register for any particular event, so we are able to reach a whole lot more people. So welcome, and I hope you enjoy this evening's presentation. If you're not a member, one of the things that we do, of course, is there are other benefits. We'll talk about that next month when I get to present. But the fresh air, clean water, recreation, wildlife habitat, forestry education, those are all things that people get as a result of being a member of the Forestry Association. And for $55, that's pretty good.
So I have the pleasure of introducing our presenter tonight. So hi, John. How are you?
Hi, Lori.
Good.
Hi, Andy.
So I just need to point something out. So yeah, I stole this picture from Facebook, right? It's a great picture. But do you notice what's in the background?
Snoopy again. He's always photobombing me, I mean, no matter
he is
what,
back
there
there.
he is, back over my shoulder.
Yes, so he has a Snoopy. So. So anyhow, thank you for doing tonight's presentation. I'm super excited about this. I need to know how to take care of my moss that I have from Pennsylvania. So without further ado, I will stop sharing my screen and allow you to share yours.
All right. Thank you, everybody. And thank you, Lori and Andy. And I appreciate the opportunity to present this. This is a subject that's very near and dear to me. I actually took moss ecology as a part of my major at SUNY ESF. And under Professor Dr. Robin Wall-Kimmer, who you may know and recognize the name from her books, Gathering Moss or Braiding Sweetgrass. Anyway, I'm just going to go ahead and get started. And can everybody see that okay?
Yep, looks great, John. Looks great.
All right, so here we go. Again, my name is John Hooven. I have my Bachelor of Science degree from SUNY ESF in Forest Ecosystem Science. I'm a member of the Board of Directors for NJFA, and I'm also facilitator for the New Jersey Woodland Stewards Program. Actually wearing my New Jersey Woodland Stewards Program shirt tonight. Just to remind everybody, if you're interested in what we do, sign up as a volunteer with the New Jersey Woodland Stewards Program. Our next training program will be in September of this year. Really looking forward to an in-person presentation, hopefully. But enough of that. We will get started on mosses. I want to quickly go over. Can you see my pointer, Lori? Okay,
Yes,
good.
we absolutely can. Yep.
All right, so right up here, this is some really neat pictures I had of mosses that I collected over the past summer. This one is actually from a spruce, Norway spruce plantation. It was a Norway spruce that had died many years ago, and moss, of course, is growing on the outside of what's left of the trunk. And what you see actually growing here in the center are actually the branches that were the lowest part of the tree. I've always been really fascinated by this picture. It just really speaks to me and just says a lot about ecology and the like. This next picture right over here, I was working for New York DEC during the summer, and there is just this, the moss growing on this rock is just absolutely spectacular. This is probably a boulder of limestone. Based on the layers, it's probably part of an old seabed. And of course, you can see by the different textures, the different types of moss that are actually just living and growing on this boulder. And then of course, this is just up on top of Shrewsbury's Peak up in Vermont. And you can see moss just growing right along the trail. And if I recollect, right over here on the left-hand side, I think that's actually sphagnum. We'll be going over that in a little bit. So I wanted to start off the presentation with a quote from Dr. Kimmer from her book, Gathering Moss. If forests did offer prayers, I suspect that they would send thanks to the mosses. And I think that's a rather appropriate way to start this presentation. So the mosses. These may not be the mosses that you're familiar with, because these are not the mosses that we will be covering tonight. And I just wanted to make sure that you were all aware of that. So if you're interested in any of these mosses, you can tune into Entertainment Tonight. So what are mosses? We will start with what are not mosses. And of course, mosses, not mosses, we have Spanish moss, which is actually an epiphytic plant that hangs out of trees. And then we also have reindeer lichen. Reindeer lichen is not a moss, but everybody will assume that it is just based upon its character. Then there's other lichens that grow on trees. They are not mosses, but you can see in this picture right here, there's actually some moss growing in the center along with this lichen. And we have club mosses. Club mosses are actually a vascular plant. Green algae, which actually is closely related to mosses, but is not a moss. And this probably looks like a tide water where the water comes up and covers these rocks on occasion. That's the thing, difference about green algae from mosses is green algae needs to stay wet. And we have liverworts. Liverworts are actually very closely related to mosses, but are not actually mosses. And then pixie moss, which we actually have, that grows in the Pine Barrens here in New Jersey, which is not a moss, it's actually a flowering vascular plant. So if we look back at the history of mosses, mosses date back to 500 million years ago. They were the first plants to occupy dry land. And they are related to green algae. They are autotrophs, and what they do is they will actually produce their own food, just like algae. But unlike lichens, which actually will use a cyanobacteria or an algae to produce its food for it. Because mosses actually crept onto the land and were able to occupy the earth, they created one of the first ice ages by removing carbon dioxide from the atmosphere. You have to understand that our early atmosphere was loaded with carbon dioxide. There was not any oxygen to speak of. So when the mosses first came up onto the planet, they actually changed the world so that we actually have a lot more oxygen than we did before. Another effect of that was they actually created the ozone layer as an effect. It says, as the oxygen was pumped into the atmosphere, it was electrified and actually produced ozone. And we have our own ozone layer as a result of mosses. So you have to understand that the primitive landscape was very hostile to mosses. And as a result, they have learned to adapt to very hostile situations. So the bryophytes are actually a proposed taxonomic division. It may be paraphyletic, which means that they're not directly related to each other, although the liverworts and mosses are thought to be monophyletic, which they are related to each other. But this status is actually still being debated. There's about 20,000 species of bryophytes. All bryophytes reproduce sexually by spores, but they also reproduce asexually. They're sporophytes, which are the actual part of the plant that produce spores, are unbranched. The leaves of liverworts, they never have a midrib. So if you're looking or trying to identify a moss, if it has a midrib, then you're looking at a moss and not a liverwort. The hornworts are related to liverworts and mosses, but they have a rosette-like thallus. This picture down here in the lower left-hand corner is of hornworts. It's not very likely that you'll see hornworts because hornworts are actually somewhat rare. There's only 100 species of hornworts worldwide. They're thought to be an ecological dead end. But the difference, you can see these, there we go. These right here are the sporophytes, and the sporophytes of hornworts are actually long, thin cylinders that actually come up from the thallus of the hornwort. Liverworts are strongly flattened. These are pictures of liverworts over here. They have two different groups, the thallus, which you see up here, and then leafy, which actually the leaves pop off of the stem. These are actually sporophytes of liverworts. There's about 9,000 species of liverworts. So mosses are in the kingdom Plantae, division Bryophytae, and the classes are listed here accordingly. This one down here at the bottom, Bryopsidae, it represents 95% of all species of mosses. So we have the sphagnums, Polytrichum juniper, yeah, we'll just stick with the genus, Polytrichum and Andrea, representing the mosses here. So mosses growth is erect or flattened. The leaves are spirally arranged. That'll make them different from the liverworts. They have a complex sporophyte, and we'll actually take a look at some of the sporophytes as an example. They have a filamentous protonema stage, which the protonema is the first part that actually starts to grow out of the spore when the spore lands and begins to propagate. They are non-vascular, so they do not have the tubes and the tracheids that a typical plant would have. They never develop those, so they basically have to rely on their surroundings for water. Mosses do not make lignin, which is essential in plants for support. And as a result, their statue is relatively short. So they can't grow tall. Now, because okay. So we have the structures here of the mosses. One thing I want to point out to you, this picture down here, you may think of this as one single plant, but this is not one single plant. This may be upwards of maybe close to 100 plants, all grouped together and living in a community. This is one of the interesting things about mosses. Think of flowers growing in a field. You wouldn't consider all those flowers in the field to be one specimen. And that's the same thing with mosses, that basically these are just all a bunch of little plants that are all congregating and living together in a communal fashion. We'll go over the effects of that in a little bit. So basically, a moss will have rhizoids, but these are not roots. The only thing the rhizoids are good for is attaching to a substrate. They do not conduct water at all. Basically, moss are relying on either rainfall or even relative humidity or dew, any moisture it can basically get to depending on its surroundings. As we said before, they live on all of the continents. And some of the areas will be dry, so they have to rely on dew at night to survive, and others are going to be wet. And because of that, they'll have different life forms and growth forms. We have up here the calyptra, and this is just basically a cap that sits over top of the urn and sits at the top of the capsule. It's not really known what the calyptra is for. It's thought to just protect the urn. The urn is where the spores sit and are dispersed. One of the issues with that is that the calyptra actually happens to be very useful in identifying what type of moss it is that you're looking at. So we have here the sporophyte, which is at the top and will sit at the top of the gametophyte. Now, effectively, what we have going on here is the normal plants that you see out in the world, trees, whatever, the sporophyte is actually the dominant stage that you're seeing. The gametophyte is actually just a temporary stage. With mosses and any bryophytes, actually, the gametophyte is actually the dominant stage. So what you're actually seeing here is actually the part that's actually only the haploid, meaning it only is carrying half of the genetic material with it. Of course, the sporophyte is diploid. The spores, when they're dispersed, are dispersed haploid. So it's up to the two have to be able to meet to be able to procreate. And we have an example here of an actual operculum and the peristome. The peristome actually allows for the dispersal of spores. The operculum actually protects where the spores are being dispersed from. And this is of a moss that grows in the New Jersey Pine Barrens, Atrichum. And down here, of course, is this orthotrichum. So true mosses comprise nearly 10,000 species worldwide, and they can be found on every continent. The diversity is actually increases as you're heading away from the tropics. And that is unlike vascular plants, whose diversity actually increases as you're going towards the tropics. Now, the exception of that, that's for the mosses. The liverworts will actually increase as you're going towards the tropics. So sorry about that. The bryophytes are poikilohydric, and that's a word that you probably do not hear very often, but poikilohydric basically means that they rely on the moisture in their environment and determines how much water is in the environment. So that's why some mosses are able to survive in deserts and in the Arctic and in the alpine zone, and why they also are still able to survive in the jungles where it's very moist. But the difference is that will vary. Their moisture tolerance will actually vary by genus. The primary stage of life cycle, of course, we talked about before, was the gametophyte. And the sporophyte is where the spores are dispersed from. So we were talking about the idea of mosses being poikilohydric. That's one of the moss's superpowers. Some mosses have been rehydrated and start photosynthesizing again after being stored for 30 years. That's simply no other organism on the planet, unless you start thinking about tardigrades. But that's a whole different story. But as far as plants are concerned, that's a really long time to be in a dormant stage and still be living. But they also take a long time to grow. In the plants, regular vascular plants, gametophyte is the short-term stage, noted by the sex organs, such as flowers, for example, or any of the disbursements that will produce seeds and mast in trees. Again, with mosses, the gametophyte is actually the dominant stage. The sporophyte is the primary stage in plants. So the main form of reproduction in bryophytes is asexual. The asexual reproduction is less taxing to the organism, which, when you look at the history of where they came from and how they've survived, that's very important. They can only photosynthesize and sexually reproduce when water is present. That's very important. One of the reasons that happens to be water is that the Achilles heel of mosses. But one of the important reasons is that moss absorbs carbon dioxide diffused in the water. It doesn't take it from the atmosphere. It actually takes it from water. Moss sperm is motile, but it can only move in water and survive for short distances, very short distances. When mosses dry out, they stop photosynthesizing. The chlorophyll is bound to a protective protein, but the protein synthesis stops. When it's rehydrated, the cells are repaired and photosynthesis will start up again immediately. The protein synthesis resumes at this point. Mosses will live where other plants cannot. That's a very important point. And as you can see from these pictures, I've got moss growing up on top of a rooftop. This is actually sitting outside of my house. It actually covers a well pit. And it's nothing more than a piece of roll roofing with a concrete block sitting on top of it. And the brachythecium that is growing on the block and on the shingle just came on its own and just started to grow. And it seems to be very happy there. That's the thing. One of the reasons that I know it's brachythecium is that they also tend to gather on substrates that either are limey or acidic. In this case, the brachythecium likes the lime. There must be limestone in the granules in the roofing material also, which probably also attracts the brachythecium to it. And of course, we were saying before about how bryophytes have rhizoids and not roots. So a day in the life, hold on 1 second. Back here. Okay. The day in the life. Of course, we were talking before, asexual reproduction is the primary means with which mosses are able to reproduce. And they have several different ways to reproduce in asexual reproduction. They actually will produce propagals in the form of what are known as gemicups, brood bodies, or tubers. They can also regenerate with their leaves, leaf apices, shoots, branches, and bulbils, but also through fragmentation. But they also reproduce by clonal reproduction. Sexual reproduction is a little bit more complicated. They, of course, go through alternation of generations. And what we have here is the spores are released by the peristome from the sporophyte, and they will actually produce the protonema. There'll be a male gametophyte and a female gametophyte. Now, the interesting thing is that some of the species in some of the genuses will actually produce the male gametophyte as a dwarf to the female. And it could actually reside on the gametophyte as a little tiny appendage, which is an interesting fact. There's not many other plants that are able to do that. And effectively what winds up happening is the raindrop comes along and will wash the sperm into the fertilization chamber, the archegonium, where one egg will sit in each one of these. And then they will develop and produce, again, the sporophyte at the top of the gametophyte, and the process starts all over again. So you can see that if you don't have, if it's dry, you're not going to have your moss reproducing. So that's an important factor. The other factor, of course, is that, to prevent inbreeding and things like that, it's important that these sperm get moved away from where they started out from. And since they don't travel very far, it can be very difficult for mosses to reproduce sexually. So that's why, one of the reasons why that asexual reproduction is so successful in mosses. So mosses grow almost everywhere. I took some pictures here previously. This is a post top sitting in a park. One thing I want to point out to you is the moss had nothing to do with the deterioration of this post top. It's probably all 40 years old or so. It's just happened to decay through the normal course of time. The only thing that the moss may be doing is because they retain water like a sponge, it could actually be enhancing any fungi that are actually eaten away at the post top. But that's all it's doing. It's actually not causing any damage. And we have some moss sitting on a boulder, and moss growing on the stairs, moss growing up a driveway, moss growing up a wall. And this is an interesting one over here because it is actually moss growing on a single rock. This is a rock in a parking lot at the same park where this post is at. And if you look really close right here, there is actually a vascular plant that has rooted and is trying to grow in this bed of moss. That's one of the benefits of mosses. They actually act as a nursery. So in New Jersey, we have three primary types of mosses. We have the granite mosses. That's this picture right here. They have a very distinct sporophyte with this Chinese lantern type of top to them. The granite mosses are in the group Andreales. We have the peat mosses, which are Sphagnales group, and then the true mosses, which are Bryales. An important thing that we should talk about with regard to mosses is their growth form. This is one of the first things that you need to know to be able to identify the mosses. We have acrocarps, the pleurocarps, and of course, the sphagnum. Sphagnums actually grow similar to acrocarps, but we'll get that in a minute. So acrocarps, basically, those are the mosses that kind of grow in clumps. They basically grow vertically. The sample that we saw earlier showed the individual plant growing straight up. That's basically how these are. So if you look really closely at all of these are all individual plants, just all growing in the same area. These are all what are known as the growth form. And the growth form, again, is acrocarp in this particular one. The life form on this is what's known as a cushion, but we'll be going over that in a minute. Pleurocarps basically will grow like mats. And the way they grow is they will run their rhizoids along the substrate, and then they can have additional growth coming up from the rhizoid so that they basically spread just like a mat. And here we have a close-up, and you can actually see the stems of the different moss all connected to a rhizoid. Sphagnum has its own growth form, and we'll go over that a little bit separately. We're not going to touch too much on sphagnum because it's actually a very difficult type of moss to identify. And as a result, we will just basically go over it briefly and just hit some of the high points of what sphagnum is all about. I think the most interesting thing I wanted to note here, sphagnum kind of grows similar in fashion to like an acrocarp, but it actually grows a lot larger. Sphagnum is one of the largest mosses to grow. There's a lot of interesting things to discuss with regard to sphagnum. It's also known as peat moss. There's about 380 species of sphagnum. And the thing about it is they engineer their own environment. And what they'll actually do is, this is growing in a place in a bog, and it'll actually acidify the bog. And in the result of doing that is it actually suppress vascular plants from growing in there. As you get further north into the boreal forest and beyond up in Canada, there's areas where you will have nothing but bogs growing with sphagnum in them. And the reason is because the sphagnum, the bogs get so acidic that nothing can grow in them but sphagnum. The different species can have different tolerances for wetness and pH, and thus several different types of sphagnum can actually be found in the same bog. Sphagnum represents 1% of the landmass in the world, and not just up in the north, but you actually have them growing in South America, up in the Andes Mountains. They actually grow anywhere they can where it's wet. They have a greater biomass than any other single genus in the world. So life form is different from growth form. So we had just went over the growth forms, but life form is a bit different. It's determined by genetics and basically you can have different growth forms exhibiting different life forms, but it's subject to their environment. So think of, I'm sorry, with regard to their environment, they will actually manipulate the way they grow to manipulate what is known as the boundary layer. The boundary layer is an important concept to understand with regard to mosses, because think of going outside on a cold, windy day like today. You put on a coat and a hat and possibly your gloves. You're creating your own boundary layer, and it allows you to go out and tolerate the temperatures. That's effectively what the mosses are doing with their life forms. They're creating their own boundary layer by the way they grow in their particular environment. You see over here, the way this moss is growing, this is actually growing out of a spring that's coming out of a mountain. So it actually grows in a bit of a pendant form where it's basically trailing, and it's able to do that, of course, because of the amount of water that it is getting from its environment. So in effect, we have these different life forms. Again, it's limited by genetics. Each species has a limited plasticity for adapting to their environment. Thus, you will not likely find sphagnum in a desert, nor would you find Hedwigia in a bog. They have a certain amount of flexibility there that they can adapt to. So we have annuals. They're pioneers, but none of their vegetative shoots remain. So once they're gone, and they basically are only propagating again based upon the spores. We have short turfs, which you can find in open mineral soils and on rocks. The tall turfs and forest floors are in temperate zones. Cushions, which are on rocks, bark, the Arctic, the Antarctic, and also in the Alpine. So the cushions are actually in very rough areas. Again, one of the reasons is they all grow close together in a clump, and that way the wind's able to blow over top of them without affecting the mass of their growth. Then we have mats, which are very popular. They grow on rocks and bark. Wefts, which grow on the forest floor of the temperate zone. Pendants, which are epiphytes, they grow and basically hang off of trees. Tails on trees and on rocks in shade-loving areas. Fans on vertical substrates in wet areas. The dendroids, which grow like little tiny trees that run along the rhizoids and just kind of pop up. And then streamers, yes, there's actually moss that grow in water. And these are aquatic. They will actually grow in either streams or they can also grow in lakes. I include this along here, and I'm going to give to Lori a copy of this presentation for your reference on PDF that she'll be able to send out to all of the people who attended tonight. So that's what this is. So don't get worried that, you know, it's a little bit much and you can't read it. You can go back and reference this at any point when we send out the PDF. But this is from Gleim's Bryophyte Ecology. This book is actually listed in a reference and is available online from Michigan State University. I actually talked to Dr. Gleim, I communicated with her via email. And I'm actually in a BryoNet group with a whole bunch of other bryologists around the world that are studying all kinds of mosses everywhere. It's quite interesting. But anyway, the life forms are typical, and they typically will associate with different genre of associations. So like, for example, if we look at We were talking before about polytrichum, which exists in the pine barrens. It's a tall turf, and you can see its family right here. Also sphagnum. So this will be available for you. So these are, I took this from the Minnesota, hold on one second. Let me back out here so I can get the name of this. It's the Mosses and Liverworts of Minnesota Field Guide, where I took these pictures from. Ooh. Apologize, we'll go back to where we were. So we have basically turfs here, and we list short turfs and tall turfs. Here we see Polytrichum junipernarian. Yeah, I'm not going to try to say that. I'm screwing that up. And this is actually growing in my place down in New Jersey Pine Barrens. It's a substitute for the front lawn. You can actually see some grass growing in, but the moss actually takes over and does much better. So this is a turf. Cushions basically will grow in the most extreme of environments. We have two turfs here, Orthotrichum, which this was actually growing on a rock, and Leucobrium glaucum, which was actually, again, growing in my front yard. You can have small cushions, and you can also have large cushions. Mats will grow on boulders. You can have smooth mats, rough mats, and also alloy mats. Wefts are a bit harder to describe. It's almost like a mat form, but the difference is, and you really can't tell from either one of these pictures, but it actually pops up a little bit because of its growth. Almost similar to a cushion. So figure like the cross between a cushion and a mat. That would be a weft. Pendants, of course, these grow on trees, mainly in the tropics and the rainforest. And while I was researching, looking for an example to show you here, it's not this kind of pendant, but apparently if you search for mosses online and you're looking for pendants, they actually sell pendants that have mosses in them. It was quite a surprise to find that. Then we have the dendroids. Dendroids are actually interesting because, again, you see along here on the bottom, the rhizoid is growing, and then you have like these, what look like little trees that actually grow up. And when this happens, they actually can grow, I want to say pretty big, but we're talking in relative terms. And one of the problems with when you're looking at all these pictures and you look at any identification books online, you can be deceived by the size. You're thinking you're looking at things that grow the size of blades of grass, but a lot of these pictures are actually taken underneath a hand lens to blow them up and make them a lot larger. So, but actually, Clemicium, as shown here, actually grows rather large. It can be 1 or 2 inches tall. And of course, talking about the streamers, this is from one of Gleim's papers, Adventures with Stream Mosses. This is Fontanellus, and it actually is growing in a stream. And that's what a streamer is. So that's the streamer life form. So this basically just goes over the different types of life forms. Once again, briefly, we have the cushions, the turfs, and the mats, and the different types there. Why does this matter? Well, I put this actually together minutes before we started this presentation. It was actually out of a sketch from my class that we did. So if we're looking at a river valley, so we have low soil moisture at the top and high soil moisture at the bottom, you can see over here, everything in green shows the different types of life forms. and where they will be found growing in the river valley. So you have the short turfs and the short mats in the areas with low humidity at the top that are getting more sunlight, and where there's less light, you'll have the thalluses and the dendroids growing. So looking at back to some of these pictures where we actually showed the life forms, you can imagine that the dendroids I took pictures of here were actually probably growing in a wetter area, for example. And same with the pendants. The wefts, of course, growing in a drier area. So that's the importance of the life forms. If we look over here, and this is just an example of showing the elevation change with the life forms, we have the turfs growing at the top, higher up, and the wefts growing towards the bottom. On rocks, that'll change. You'll have smooth mats growing towards the top and dendroids growing at the bottom. So referencing back to that other picture I had of Clemicium, that was actually growing on top of a rock in a wetter area. Sphagnum, again, is kind of breaking all the rules of all the other mosses. It's much different than true mosses are. One of the things that you can note with regard to its structure is you have the gametophyte, and then on top you have what looks like this flower. It's known as a capitulum. And the sporophyte is a little tiny extension from the capitulum itself. Now, the interesting thing about this is as these grow, the leaf cells consist of what are known as dead hyaline cells interspaced by chlorophyllous cells. Hyaline just basically means that they're clear, and that's what's illustrated in this picture over here. And then you have the green chlorophyllous cells growing in between, which will actually give it its color. So the structure of the sphagnum actually is growing. It's mostly dead. And it just keeps on growing up that way, which is one of the reasons why in the bogs in the north, they just keep growing and growing on top of each other. And you could have very thick amounts of peat, which we then harvest and gets sold for us to use in our gardens. So this right here is an example of the different life forms all growing on a boulder. As you can see, we can see the mats, we can see turfs growing up around here, and then we can also see cushions, large cushions, and if you look down here, even small cushions. This is actually in the Adirondacks, and was just a really, really intriguing thing to see. And of course, then up here at the top, what you have is you'll have a collection of organic matter in the form of leaves, dust, dirt, and eventually this actually winds up producing a surface where vascular plants will grow because they'll be able to root. This is how it all starts. So when we look and we go outside our doors and you walk into the forest and you see what's happening around you, it all started with a mineral surface that started with mosses. That's important to know because it's the first step of succession. Oh, basically, with regard to moss identification, if that's something that you're going to get into, you will need a hand lens. And if you actually want to get to a point where you're identifying to a species level, then you'll actually need a dissecting microscope. Now, some of the references I've included with this presentation will actually allow you to do identification down to the genus level with just a hand lens. The publication that we have available actually comes from Rutgers University. There was a doctor who did a study back in 2017 and basically listed all the genuses of mosses that grow in the state of New Jersey. So I included that in the reference. So based on that paper, we're going to basically look at how you would identify a moss. So once again, you need a hand lens, a squirt bottle with water, and that's important because mosses will look different when they're dry from when they're wet. And the most interesting and fascinating part of that is when you wet a moss for the first time, when you're doing this, and you see it go from dry to wet, it almost springs to life instantaneously. It's actually a fascinating thing to see. So if you have the opportunity to do that, I definitely recommend that you try it out. Now, where the moss is growing can be the most important characteristic. There's some mosses, like I said, sphagnum loves acid, but there's other mosses that also like base. And as a result, you will find the most intriguing and interesting thing. In the Adirondacks, there's an old concrete base of an old antenna from a radio tower sitting on top of a mountaintop. And if you ever go and check it out, there's mosses growing on top of the mountain where, the Adirondacks are granite. So most of what you find growing up there love acid, except at the top of this mountain where there's a concrete structure where there's actually base loving mosses that are growing on the concrete base that just happen to blow in with the wind. This picture right here is actually from Jerry Jenkins' book, which is also included in the list of references. And this is basically, he illustrates how to identify different mosses on where they grow on the tree. And he's actually got several different pages in the book that are dedicated to this. So that if you know what your substrate is, if you're looking at a limey boulder or a granite boulder, they'll actually show you where on the different boulders or what have you, or in a valley or up on top of a mountain, where different type of mosses can be found growing. So you see Eulota up here at the top, Orthotrichum, which I actually have some pictures of, and we'll take a look at those. And Leucodon a little bit further down, Hypnum, Anomodon, Brachythecium growing towards the bottom. So you can see that's very important to know. So like, for example, if you think you have a Brachythecium, but you're identifying it all the way up here on top of the tree, you may want to double check because it's probably not a Brachythecium. That's one of the reasons why it's really good to narrow things down based upon where they're growing and also on the substrate. You'll find that mosses grow on anything from rock, soil, organic materials, and also living in dead wood of trees. This is a close-up from the first slide of this presentation of the moss, and I just wanted to illustrate once again that we have different mosses that are actually growing on this boulder in different areas of the boulder. The other important thing, again, I wanted to note is how the leaves and everything accumulate as a result of the moss growing. And then we actually can have ferns that are actually growing and starting to root in soil that was produced by the moss. Moss is truly fascinating. So if we're looking at basic moss identification, the first thing we want to do is identify if we're looking at an acrocarp or a pleurocarp, or is it sphagnum? And here, of course, we have a close-up of Orthotrichum. This illustrates what happens if you look towards the edge of the picture. You can see how it's all closed up tight. But if you look towards the center, it's all opened up, because what I did was I actually dropped a drop of water on the moss. And this is a cushion. You can see in the background that there's actually lichen. This is a cushion moss, which is actually growing on tree bark. And as a result, the moss opens up just like a flower and is looking for the sunlight to start photosynthesizing again. So again, this is an acrocarp. So that's one of the things that we will look at. The next thing, and this is why you need the hand lens, is because you're going to get in really tight and really close and look at each of these leaves and determine whether or not they have a midrib or not. And I'll show you pictures on the next page. You can have different types of midribs that help you to identify the moss. Another thing you're going to look at is the shape of the leaf. And you're going to look and see if it has what are known as awns. Awns are hair-like structures that actually sit at the end of the leaves. And they have a function to help the moss, especially in drier environments. Other things you're going to look at are leaf size, the leaf apex, and also the margin, whether or not it's serrated or smooth or entire. The branching of the moss is also important. And I've included a link here at the bottom. This is the Northern Forest Atlas. This is free and will help you in identifying mosses. Oh, you know what? I want to go back here and take a look. Another thing here, these are the capsules from the sporophytes that we were talking about before. These are all very unique for each species of moss. So it can help you narrow down, and this is how I was able to determine that this is orthotrichum based upon these capsules, because they look like little fat flask. And that's one of the things that will help you to identify the moss. So here we have the different types. These are what are known as the midrib, or also the costa. So you may see it listed as either, but more than likely, if you're looking at any reference book with regard to mosses, it's going to be listed as a costa. You'll also see other structures that I didn't put in here just for a factor of time, but each of the leaves of moss get very intricate and have a lot of details in them. Most of those are so that they can retain water. They're very important because, once again, we talked before, there's two different ways that mosses will take water. They can do it ectocurrent or exocurrent. And basically that'll determine, it will help you determine whether or not they live in a dry environment or a wet environment. So again, these pictures right here basically are just showing the different costas. And these are the different leaf shapes that you would see. And once again, identifying the different leaf shapes will also help you to identify the moss. And we have the apex, and I threw in some definitions over here of the different type of margins. There were less specific in the book with regard to the edge characteristics. So you may be more, if you've got access to a botany book or a dendrology book, it'll help you to see some of the different types of edges that are out there available. So And then they have the branching patterns. Of course, we have unbranched, which would be like a polytrichum, dendroid or tree-like, which we see over here, which would be like clemicium, and pinnate, bipinnate, or irregular. So based upon that, we have here a picture of moss that was growing on rocks at Clark Reserve Park in near Janesville in Onondaga County, New York. You can see closer that this is a mat. So we're looking at a pleurocarp. And based on information that I was able to deduce from looking up close at the leaves, I was able to identify this as, where is it? Oh, I'm sorry. Pleurozium cerebra. And one of the reasons is the telltale identifier with this is the redness that's found when leaves are actually connecting and branching from the main stem. This is another small, tiny moss. And once again, you can see the edge of a rock cliff right up here. And this little tiny patch of green right here is actually this growing right here. And you can see we got a nice midrib in here that you can see nice and clear. And this is Encalypta proceria. And it's also a lime-loving moss. Now, one of the things I wanted to point out is, okay, you can see how it's growing nice, tight, and wedged in here, okay? But you can also see that there's also other mosses growing around it as well. So. And here's a list again of the identification resources that I'll be making available to you. So if we're looking at ecology, I'm referencing here, this is Grimes CSR triangle. J. Philip Grimes actually put together an ecological model of the life strategies. This is basically to understand that vascular plants are up here with competition, which is what the C stands for. Down here to the right, you have rurals, or the disturbing loving areas, or the areas over here that are subject to a lot of stress, like the Arctic or deserts. So if we look over here at the triangles, you can see that perennial herbs and ferns are actually occupying the center of the triangle here. Trees and shrubs are very competitive. You see the bryophytes are not able to compete against vascular plants. So basically they're working their way into areas of the triangle where nothing else will be growing. So they actually occupy this area between stress and disturbance. The lichens, of course, are occupying the stress corner down here. But you can see there's a bit of an overlap here between the lichens and the bryophytes. And this actually, when I was doing some research for a moss paper that I was writing, I started thinking about this. What you see here is this is actually a moss that is growing on the end of a branch that was just hanging out in the forest. I actually saw this over the summer, and I was just so fascinated by it that I had to take a picture of it. This is Eulota. It's probably Eulota crispa. Once again, you can see the sporophytes growing with the calyptra up here at the top. So they actually haven't released their spores yet. But this is just a fascinating species, specimen that I saw growing at the end of a branch in the forest. And here we have probably orthotrichum, but it could be Eulota. In this forest, this was growing all over the trees, living trees. This is actually a dead tree that fell down. But this didn't have anything to do with why the tree fell. it just so happens that, mosses will hold water, but if the tree had something else that it died from as a result, it was just coincidental that the moss was living on it. So I was collecting mosses for a moss ecology project, and I noticed that I found lichens growing on tree bark alongside with the mosses. And I started to think, is there a correlation or is this just coincidence? So a student of ecology is naturally interested in the relationship of organisms growing in the same proximity to determine their effect on each other. Both lichens and mosses are autotrophs. The organisms require to varying extents a certain amount of water and light and favorable air composition, but they cannot compete with vascular plants in a less stressful environment. And thus, that's why here they are growing on the side of a tree. So we have mosses growing here and the lichens growing with them. Now, is there a relationship or not? That's the question. So I did a little bit of research, and the lichen-moss relationship in the forest is well known. The USDA actually identifies, the US Forest Service recognizes a lichen moss layer in the forest as a decomposition layer. Lichen moss mats sequester 1/3 of the world's carbon in terrestrial ecosystems. Virtually all forest ecosystems have a lichen moss layer that is providing essential ecosystem functions. The suppression of microbial decomposition by the lichen moss layer slows the release of carbon dioxide to the atmosphere. That's important. Mosses store more water than lichens. They will actually store up to 100 times more. So you can see where, even though both of them are poikilohydric, the moss, the lichen will actually benefit by having a moss neighbor. So in arid areas of the world, lichens and mosses, along with algae and bacteria, are associated with a soil feature which is known as cryptogamic crust. And cryptogams basically are what we call lichens and mosses. Anything that grows from spores are cryptogams. In one example in the New Jersey Pine Barrens, and the study is in the reference area, Cladonia species or reindeer lichen, which you see here in the light green, and Polytrichum have an inverse relationship to each other. In this environment, the two compete for resources. So there's some years where it's wetter, and then you'll see more of the Polytrichum. And then some years where it's drier, and you'll actually see more of the reindeer lichen. But what winds up happening is a moss lichen mat like this in the Pine Barrens could be as old as 100 years old. And it actually is suppressing vascular plants from growing there. It's an interesting phenomenon. So if we study primary succession, which primary succession is the type of succession that you have when you have glaciation or a meteor strike or a volcanic eruption. So we're talking about no organic matter whatsoever. Lichens will actually start populating an area first and prep them for lichens and mosses to further colonize the area. As the succession proceeds, soils are made, weathering rock, deterioration of the lichens, and organic matter starts to grow and build up, as we saw on those earlier pictures with regard to the moss growing on the rock with the ferns growing on top. And what we see over here to the left, this is actually a yellow birch that has rooted on, I believe that's a rock where there was moss growing on it. And same thing over here. This is actually a balsam fir that started to root, and you can see it's like a little nursery down here growing on top of this rock. Over here, of course, we had a tree that was cut down. The moss basically overtook it, and voila, you have another balsam fir which is growing right out of the moss mat. So succession all starts with lichens and mosses. It's very important. And this is even in areas where you have forest fires, you'll see the lichens and mosses come in immediately afterwards to help with the healing process of the forest. And this is actually a red maple, which is started to grow out of this moss mat right here. So moss growth can identify favorable and unfavorable environmental conditions. There have been moss that have been used to basically find out if there's a toxic contamination going on in a neighborhood. There was a study that was done in Portland, Oregon, which I found to be very interesting, where they identified there was pollution that was going on as a result of, they basically took samples of mosses in neighborhoods and were able to use them to see what the air quality was like. Yeah, identify different types of moss growing in an area can also tell us a lot about the successional stage of the forest. Moss growing in a particular area can give us insight into the history of the site. And as they take up nutrients and make a hostile environment more benign, herbaceous plants, grasses, shrubs, and trees will eventually move into the environment. And here's another example right here. This log was affected by the fungus. It could have been killed. This tree may have been killed by this fungus, Krishmaria dutsa, brittle cinder fungus. And now the moss actually is growing on top of the log, and you can see vascular plants are starting to grow in and around the area as well. So the moss is actually acting as a facilitator. Right here, you have a tree that basically toppled over. And what's interesting is you have what's known as a diaspore bank. So all this moss started to grow in afterwards, and this is atrichum. But the thing about it is you will not find atrichum growing in this forest. It's only growing in the area where it was disturbed. So this is the first thing to grow, but it winds up getting replaced by other mosses eventually. So it's the first stage of succession. So that's the interesting thing about diaspore banks. So the conclusion of the research: in some ecosystems, a mutualism does exist between lichens and bryophytes. The ecosystem becomes dependent on this mutualism as the cycle of succession progresses. Lichens and bryophytes can compete for resources when occupying the same niche, and a relationship can be mutual. It's situation dependent. Environmental and dispersal factors determine whether a mutualism develops between mosses and bryophytes, and lichens and mosses can coincidentally exist in niches because they tend to favor similar environments, but in these environments, they do not likely compete for resources. So some moss myths. Mosses do not grow on the north side of trees exclusively. They will grow wherever the light is able to hit the tree. Mosses do not compete with your lawn. If you have mosses growing in your lawn, it's because your lawn is nutritionally deficient, because under normal circumstances, vascular plants will always outcompete mosses. So if you're lucky enough to have mosses growing in your lawn, that just means that the mosses actually prefer it, and the lawn is nutritionally deficient. Mosses do not harm your trees, so you don't have to worry about that. Mosses can live in the direct sun, although most prefer shade. Some mosses are very drought tolerant, and mosses can uptake some nitrogen from the soil. So I threw this in here. We'll go over it quickly, but I think you'll want to reference this back if this is something that interests you, because Lori had suggested about tending mosses. So why would anyone want a moss or lawn or garden? Mosses require very little to no maintenance. They do not root. They grow on compacted soil where grass will not. Many people complain about moss in their grass, but moss cannot compete with grass. Mosses are always green, except sometimes when dry. They're resilient in drought and cold. And you can see this is one of my neighbors in the Pine Barrens who has a moss front lawn. And the nice thing about it is in the summertime, when the leaves are out on the trees, The sunlight cannot hit the forest floor, but he's got a nice green lawn because of the moss. No fertilization is needed, so you don't have to worry about pollution and runoff into waterways. No pesticides are necessary. Can be started at can be the start of an early succession to a native and natural state. I actually have mosses that grew in my front yard just from leaving it go and letting it do its own thing. And the net result is I now have native wildflower that actually has grown in St. Andrew's Cross. Very interesting to see that now, and it occupies about a quarter acre of my area. And this all, again, starts with the succession because, you know, where you have different mosses coming in, then you'll have the succession of other plants that will basically start to come into the area. And because of the organic matter and the moisture that the moss provides, it's like a nursery. It could possibly slow the spread of fire. I actually want to research that a little bit further, but theoretically, it's a good possibility. So it'll probably act a little bit better than having grass dry out in your front yard if you're in a fire-prone area. It has ecological advantages for wildlife too, because there's all kinds of nice little critters that are living here in the moss. And, you know, it just basically goes up the ecological scale. So you'll have amphibians coming in to eat after them and such. So if you want to start a moss gardening, my best advice for you, have an area that is shaded or semi-shaded. That's important. Mesic environments are best, and keep them free of weeds and debris. Remove all the vegetation, and the best thing to do is let the natural spores populate the area. Soil conditioning may be necessary depending on the type of moss that may be present in your area, and encourage mosses already present in the environment or on your property into the area. Again, they will reproduce asexually by fragments and the like. And there's more resources also available online. And that's basically all I have for tonight. I know it's probably a little bit longer than you expected. I put an awful lot of information into that. If you have any questions, we'll go ahead and go to the Q&A and we'll start there.
Oh, there's questions for sure. Great questions too, by the way. This was fantastic. I wish we could go longer, actually. So I think I'm going to start from the top because it's kind of sequential. So I don't know. Can you see the Q&A, John? Because I can read them.
I'm
but
looking at
okay.
Correct me if I'm wrong. So I'm looking at Barbara.
Yep.
Interested in landscaping with moss. Again, I kind of shortened things up because I went a little bit longer than I anticipated with some of the stuff. But my understanding, and, you know, again, talking from my moss ecology class with Dr. Kimmer, she has heard of people coming up with these mixes and brews, and basically she advises against that. Basically, it's just a simple matter of keeping an area wet, and keep it wet and free of vascular plants, and the moss will come in eventually. As an example, I was thinking about this. I live up in Syracuse, New York, where I'm at right now. So my landlady had a driveway of pavers put in 2 years ago, and nearly 90% of the cracks now have moss growing in them just by themselves. She didn't do anything, you know, they're just growing, growing there on our own. But we actually have a lot of moss growing naturally in the neighborhood that's growing on top of rooftops on shingles and the like too. So that could have something to do with it. So
it sounds like leave it alone and it will come, right?
Yeah, basically, you know, I basically, my place down in Jersey, I stopped fertilizing the front lawn, and that's all I did. And the moss basically took over. It's just to a point right now where it's you know, taking everything over. It's pretty amazing to see it, actually. Ed asked, where is commercial sphagnum peat moss harvested, and is it done sustainably? Right now it's harvested in Canada. That's actually a very good question, because there's been some controversy over whether or not it's being done sustainably. It's being studied, and they've actually been making some progress into trying to reestablish some of these bogs where they've been harvested with mixed success. So it does become a bit of a controversy online for alternatives to sphagnum, but I think it's important to recognize that some of these places that are harvesting are actually attempting to reestablish the bogs. So I guess you want to look in and see if the sphagnum is actually being responsibly harvested. So Clark asks, he's got a question about sphagnum also. That's a good question, Clark. I'll have to get a clarification on that. He basically asked if, with regard to my comment about sphagnum and the largest single species, I actually have to need to get a clarification, but I was going to run out of time, so I wasn't able to research that and find out specifically. I think it could be with regard to all moss species, since that was the reference. So. But I'll have to clarify that and shoot you a message when I find out. Pat asked if she wants to go ahead, Lori.
She, Pat, you answered her question already, so she
okay,
said it
good.
down below. So I should have gotten rid of that. But so Pat, if you have any other comments on that, but she did say that you answered her question, so it's good.
She actually brings up a good point too. She mentions that she's overwhelmed. And don't feel bad, because I got to tell you that my first time, the Clark Reservation, which is if you guys love mosses and you're interested in ever traveling to central New York for a trip, you got to make a trip to Clark Reservation. It's a fantastic area. But my first
do a
time
moss
out
field
there,
trip, right?
Yeah, my first time out there for a moss collection project, I got completely overwhelmed, and it's not hard to do. You know, in a nutshell, what I say is practice, practice, practice. That's the best thing. So, Jim asked, "Hi, Jim. Walking in the woods in the winter with no leaf canopy, the most mosses are bright green, greener than summer. Is this due to the increased photosynthesis with no canopy?" I would say so, as long as it's not freezing, the mosses will be photosynthesizing, yes. So do mosses live on rocks or dead trees? Get any nutrients or minerals from the host rock or decaying wood? Absolutely. It comes in the form of the water though. There may be some nutrient transport in the rhizoids, but I'm going to say no. That's my gut feeling, but I'm pretty sure that it's going to be coming from the moisture as a result.
John, you mentioned the freezing part, so they're not going to photosynthesize when it's freezing. But
that's right, because they need the moisture.
Water.
Yep. Yeah, and
okay.
They need the carbon dioxide. So when it's freezing, they're not getting the carbon dioxide, so they basically are just sitting there.
Okay, and they just reinvigorate when the thaw comes. Oh, he froze a little bit there. Okay, are you back? Looks like he froze. Boy, there's more questions coming in too. John, you need to come back. Up, you're back. Are you back? Or is that you, Andy?
I think it's frozen in Syracuse.
It's frozen in Syracuse. There you go. Okay, hopefully he'll come back and he can answer some of the other questions. We'll give him a minute because if not, we'll just make sure that he answers all those questions. Up there he is. Maybe there. Are you back? He tried.
Automatic cutoff at 8:30.
Yeah, what there you go. Okay, so I think give him another second, because John, are you there? Okay, so I think we will probably have to answer the question in our follow-up email. Hey, John, are you back?
He's there, but he's muted.
Yeah, you have to unmute yourself, sir.
Yeah.
Oh, come on. Technology has been fantastic for everybody except for one of our wonderful attendees. But so are you back?
I'm here. Can you hear me?
Okay. Oh, yeah, you sound great now. That was weird.
Okay. Yeah, yeah, I have internet problems, unfortunately, so.
Yeah. So there's just a few more questions. I don't know if people want to hang out, we can answer them real quick, or we can always do some follow-up in the follow-up email as well. But you want to try to hit some of these?
Nick had mentioned moss cannot photosynthesize without water, but plants can. But actually, you see the plants are actually getting their water and are photosynthesizing because they have water inside the plant itself. And the thing about it is they require turgor that actually the water is actually coming up from the ground and is basically falling out the leaves. And what happens is if the tree or the plant dries up and they stop releasing the water, then that process basically shuts down. So they stop photosynthesizing as well. That's the simplest way I can answer it. It's a little bit more complicated than that. But yeah, they actually need water to synthesize as well. So Pat asks, do mosses have seasonality? It seems that I see sporophytes or fruiting bodies even in the middle of winter. Some of them could be left over. They're not going to be actually putting those out, and actually, unless they're actually in the growing season. When you see plants at fluorescence in the dark on rocks or trees, are these mosses, lichen, or something else? Jim, that's a good question. I will have to get back to you on that. I don't know for sure. I do know that there are some fungi that will fluorescence, and the reason they do that is to attract bugs to help them spread the spores around. Does moss damage a roof in any way? I hear roofers say yes. Understanding what winds up happening is the moss actually retains water. It's not like they have roots, so they're not going into a roof per se, but they are actually retaining water. So that process itself can actually be damaging to a roof. So I would be concerned about that. Of course, that's also hearing a roofer say that. And the only information I could find out online was roofers saying that they damaged the roof. I couldn't actually find any information, that was not biased. So I can't answer that in all honesty without doing a little bit of further research. So. Raquel actually transferred from ESF from New Jersey. Oh, cool. Raquel, I'm still on ESF's website email. So you can start typing my name. It's John Hooven, and it should auto-populate. Send me an email through the SU mail server, and I'll be able to answer any questions that you have with regard to that, okay? And with regard to bryophyte research, it's funny you ask because I contacted Janice Gleim, and she suggested that if I want to do any postgraduate research into mosses, I'm going to have to go to Europe. So I don't think I'm
That's
going anywhere
exciting.
anytime soon. So Peg asked, her friend in Tom's River created a beautiful moss paste by grinding up moss in a blender and adding buttermilk.
Wow.
I understand from Dr. Kimmer that actually that doesn't necessarily produce any results. That's a popular trend on the internet, but they did a little bit of research and they haven't been able to establish if it actually helps or makes a difference. So just the easiest thing to do, there are some places online that will sell moss. You just got to be mindful though, because moss can be invasive, just like vascular plants are, that you're getting appropriate moss that's already in this area. You don't want to basically use mosses that you're bringing in that will wind up being invasive and, you know, detrimental to our ecology. So.
That's great advice. Hey, John, Raquel asked in the chat, you mentioned the Bryanet group. Is that open? Of course, she's going to ask this because is it open to students with a passion for them? Like, is that open to anybody?
So. You just basically got to contact Dr. Gleim for access to Bryanet. And now I'm in the group and I get these really weird emails with, I mean, it's way more technical than even I can understand. But I was actually a part of the discussion with regard to mosses and archaeology, which was rather interesting. And that actually wound up coming up with some really interesting answers as a result. So to answer your question, so.
Good stuff. Okay.
Do we cover everybody?
Yeah, the only other question was in the chat is Doug wanted to know if there's a species of moss that is best for amphibians, such as salamanders, and how to maintain it in aquariums.
That's a pretty good question. Lori, could you actually send me his information?
I shall. Yep.
Because I'll have to do a little bit of research on that particular topic.
Okay, fantastic.
I probably have a little bit of information available to me. I just have to dig it out and maybe do a little bit further research on it just to make sure I'm giving you an accurate answer. So.
Okay, sounds good. And we do have an offer for somebody to possibly do a basic talk on lichens. And John, you and I have talked about that over the years, right? Remember, we really wanted to talk on lichens. So we might be able to follow up with Pat and get that done. So you might see that on the schedule for future backyard forestry program. Yeah. So I'm excited.
Peg, I will be providing a PDF copy of this that has a bibliography available. In the meantime, let's see if I go to, I'm not forwarding. Here's a brief list of references. If you want to take a screenshot of this, but I actually have, this is probably with regard to most of the material I have here. The other 2 pages basically were research into my research paper that I did for the moss ecology project. So, but most of this material actually, these are the books and websites that I actually referenced right up top here. Everything else basically comes into pictures and graphics that I use for the presentation. So what you want to concentrate on is right up top. So
wonderful. Okay. I think it's a wrap. Some great comments in the chat. Everybody is super happy with the presentation. Wonderful. You know, look forward to reviewing it again. I'm going to try to get the recording up and posted to everybody as quickly as I can, because you know, that would be great. So you send me the PDF and then we'll get everything together for people. So
all right, very good. I want to thank everybody, and keep in mind, like I said, this is presented for free by the New Jersey Forestry Association in cooperation with Rutgers Cooperative Extension and the New Jersey State Forest Service. But please, we are a nonprofit and we look forward to you considering becoming a member of the New Jersey Forestry Association so we can keep providing these type of programs to you for free. Thank you.
Well said. Thank you, John. Take care, Andy. We'll
Okay,
see everybody next month.
Thank you, John.
Thank you, everybody. Take care.
Bye-bye.